Red hot take alert. DS9 is the best Star Trek series there is. You can agree/disagree down in the comments below. However, I think we can all agree this DS9 comm badge is sweet. This LED silicone diffused lighting system just takes a project to the next level, especially if you pair it with an Arduino microcontroller for custom lighting effects. So join us in this two-part trek where we'll go over the materials needed, the design, cutting it out in the first video, and in the second video, we'll go over putting it all together, the wiring, and a brief overview of the coding. Speaking of brief, I need to brief you on our sponsor, CNC Lab. With their long mill MK2, you can trek further than before. The MK2 48 by 30 extends your X-axis cutting area out to 48 inches while still providing the rigidity and reliability you can count on from the long mill. You can find out more about the MK2 and upgrades for the MK1 in the links below. All right, we're going to start off this video going over the materials used in this project. To start off, I went with the Arduino Pro Micro. Now, I went with this instead of some of the other controllers out there because I wanted the ability to have them do what I wanted them to do. Plus, I totally wanted to frustrate myself and, make this project take, way longer than it needed to be. However, I learned a lot using this, and we'll get into that going through the wiring and the coding later on. I also went with the Pro Micro because it does have a 5-volt out. Now on this board, it does come as 3.3 volt, but you'll need to jump the J1 part of the board as you see here. So you just get your soldering iron and some solder and solder that together to make this a 5-volt board. The other reason I went with 5-volt is because I went with the WS2812B Addressable LEDs, which are 5-volt. If you look at some of the other LEDs out there, they're going to be 12 or 24 volt, and I don't want to be messing with power and converting it down. So that way I run one power, 5 volts to both my Pro Micro and to my LEDs. Now, if we take a look at these LEDs, you'll see there is a red and white wire that's coming off. That is for additional power. Now, if we were just powering, let's say 6 of the LEDs in here, we could fully run this off the VCC power out on the Arduino Micro. But since we're using a lot of them, we are going to need a straight 5 volts to the LEDs themselves. Now, these LEDs are, so this strip, as you can see, has this silicone outer coating, and the top part has a diffused clear and even a side here. And this side where you see these little markings, that's where you can cut it. We'll talk about that a little bit later in the build part. I really like these LEDs. They look really great and they're really fun to work with. As you can see inside, here's a cut strip. It is just your normal LED strip inside there. And this silicone outer casing is just diffusing that light, giving you that awesome look instead of those individual little LED cells or LED lights that you see. All right, we've talked a lot about both the Arduino and the LEDs being 5 volts, so we need a 5-volt power supply. For me, I use this 5-volt 8-amp power supply. Now, it did come with this little barrel connector doodad that you can, with a screw terminal for your wires. And while I did use it while I was testing things out, I did eventually switch over to a barrel plug cord and just soldered the wire together. Next, we have our resistors. Now, I used 330 ohm resistor on this project, and I used 3 of them because I have the data lines from the LED strips on 3 different pins, and we'll talk about that later. Don't let that scare you off. Also, I used one capacitor, 100 UF 6.3 volt. And that's just to make sure our power going to the LED strips is nice and even. And last but not least, a button. And I will admit to all of you right here and right now, when I designed this, I totally forgot the hole for the button. I put a hole to run wires through, but yeah, it wasn't big enough for the button I had. It's still too small for this one. But I super glued it on. You'll see that in a little bit. But on this, on the buttons, also make sure you keep your voltage the same. This is a 5-volt button, and this one has an LED in it. That's not what I used on that. I used just a regular 2-pin button. I had a 24-volt LED button. Whew, that just had to come out of the project. No fun, no fun. Next, you're going to need some electrical wire. Now, I would recommend getting 3-strand cord where you have, red, white, and whatever other color it wants to be. That way you can keep all your positives and negatives color coded and your data lines coded. You don't need, 8 different colors. I mean, if you do, you want to, fine, great. But at least try to do 3. One of the annoying things I found is some people use red and black for positive and ground. Some people use white and black. You're going to need a multimeter. I know I don't have it on this list, but get a multimeter so you know exactly which is which. All right, and we talked about this a little bit earlier as well, but barrel plug connector cable. I grabbed some of those. They were really cheap, really nice and easy to quickly connect and disconnect the light from the power source, especially when I was programming and testing out the LED patterns and the code. So those are a nice but not must-have. Also, JST connectors. Again, this is not a must-have, but it's a nice-have, as all the LEDs so far that I've been working with in the 5-volt range use the JST connector. And I got one of these little do-it-yourself kits. I've used the DuPont ones or whatever they're called, the straight line ones. These, they just seem to have a little bit better in connecting and staying together because they have that little clip to keep them together. But if you do these, you're going to need a crimper. They're not scissors, can't do that. All right. So that is an additional cost, but again, that's not necessary. But it is nice to be able to unplug something, plug it back in, and if that's not working, plug it into something else and see if that's working, so you can test if your connections are bad, or if you just have, you crimped it wrong, didn't do it right, hey, not pointing any fingers. Or if you don't want to go the JST connector route, you can just always solder your wires together and do it that way. As we're using these silicone covered LEDs, you're going to want to get some of these LED tube strip end caps. Now there's several out there, so make sure you measure and get the size that fits the LEDs you got. Mine were 8mm, and these have 2 holes. You can cut it down the middle and fit all 3 wires through if you need to. So that's just for end or even restarting and redoing the beginning of a strip. After that, Permatex 850 clear RTV silicone. Now, I don't know if this was the best choice, but man, does it stick. So I tested out some of the cut pieces of the strip and glued them in here into acrylic. And this ain't coming out. This is the Permatex 850, and this is CA glue. I mean, it's bending, it comes out. Now, did the super glue CA glue hold? Yeah, but it was more, anytime I played with it or started, you could start to feel it loosening. Would I recommend the Permatex 850? It's a little messy. I may try to find something else, something a little bit better, but man, everyone, when I was reading reviews, said this stuff it isn't coming off. So this is an option. Just remember, it's a little bit messy. You don't need a whole lot. A little goes a long way with this stuff. The main thing here is to get something that works with silicone, is going to keep it attached. And I should have put this higher up the list when we were talking about JST connectors and barrel plug connectors and cables and stuff, but also some wire heat shrink tubing. This is not going to hurt to have. No. This is going to make things look nice, keep things connected. Yes, I know you solder them, but you know, you don't want solder points clashing up against each other. I even ran these over the poles on the button taps. Why? I don't know. It just looks nicer. You don't have that wire sticking there. There's no chance of anything shorting. You're preventing all that. These are great. They're cheap. You can just use a hot air gun or a lighter, heat it up, and it shrinks and keeps your wires in place. Well, that sums up the microcontroller, the lights, and all the wiring and all that fun stuff. But what did I put it all on? Well, cast acrylic. I used a 6mm black, and then also I tried two new ones, which are green cast acrylic. Now these, one is mother of pearl silver, and the other was antique gold metal acrylic, and they were recycled. And I'll talk about the interesting thing on those two when we get to the cutting part, but that's going to sum it up for materials used on the project. Now let's get into the design. All right, let's talk design. So I traced out the comm badge and everything in Illustrator. You could trace that out in any of your CAD software. Nothing we're going to talk about is, you know, a special feature or anything in Illustrator that you couldn't do in your CAD software. So you can see here we have our comm badge, and then we have all these little bits and parts over to the side. But let's first take a look at the comm badge. We'll zoom in here, and you can see we have this outer part of the comm badge, we have this inner, and then we have this yellow line going around. Now this yellow line, that is where our LED strip is going to go into. So if we click here, we can see I have it set to 6.35. That is quote unquote the diameter given by the manufacturer of my bit. When in reality, it's like 6.25. We'll look at that when we get into the cam part. But I just did that as a reference point to me. Now, you may be asking, well, why did you do a line and you didn't do an outer and inner line? So making this, you know, 2, because my bit is just large enough that the LED strip will fit in it. So I don't need to pocket in between, you know, the two lines to cut. I can just take my bit, cut out, and the LED strip fits in. So that might be something to consider, is instead of having to worry about using a smaller bit and getting the right width, hey, your bit may just already fit, the LED strip just may fit in there. So you can see we have that here for this outer part here, and then these green ones for the side of the comm badge, same thing, just a straight line, well, a solid line around where we want to insert our LED strips. Also, you see these little blue things. Now, this is something I would change on the next one. I would get these to line up a little bit better in terms of where I put everything. Because, as I had mentioned on the LED lights earlier, they have a top part and a side part that can shine out light. So I always wanted the side part of the light shining out to face outwards. So for that to work, you can see here, this is where the end cap will go. And then this little piece right here, section right here. So this blue part right here, what you're looking at, that part is the hole we're going to cut for the wires to go to the back side. This blue part, we're not going to cut all the way down. We're just going to go down a little bit deeper than we normally would. And that's just to give us some room on the end cap of the LED wire, so it fits in nicely, because it is about 8mm versus the 6mm of the LED strip. Plus minus, you know, a few decimal points on the millimeters there. So that's what these blue rectangles are. That's our starting point for the LED lights. So really take that into consideration when you're putting this together, that if your strips have that outside LED light, that they are facing the way you want them to face, and that your design is accommodating to that. Now, next you see these two blue rectangles here. those are some more full hole cutouts. And that is for our mounting system. So if we go over to these pieces over here, you can see we have this big one right here with the orange dot, which I had mentioned earlier. I had originally intended to run a wire through there. Totally forgot about the button. So that will change in next iterations. So make sure your hole's big enough to accommodate your button. And then this, we'll go ahead and control copy it, bring it down here. V fits into here. Now you can see here, I gave myself some wiggle room on the side so it fits in, because this being cut is going to be rounded because my bit is round. But I did use a smaller bit. Again, we'll talk about the different bits when we get into the cam side of things. But that fits in, and that keeps the bottom part pushed up off the wall. And then the rest of these pieces, this piece, this piece, this piece, and this piece, are the top mounting mechanism. So this piece right here, just like our other piece, slots in right there. And again, it's a little, the slot is a little undersized to the hole. And then you can see there's these pink rectangles here. Now those are cutouts as well. Now those cutouts are for these pieces. This slots in here, while these slot in on the side. Let's bring that to the front. There we go, so you can see it. So you can see these slot in that way, and these will slot in this way. That is not grouped together. Make sure we're not, there we go. These two holes right here will be cut all the way through, and then I'll have two screws in the wall. So this will hang, this will be parallel to the wall, so the screws holding out can sit in there, and this can rest on the wall. All right, let's just go ahead and move all these back. I'm going to go ahead and group that though too. And then this was my attempt to make a Arduino Pro Micro holder. It was nice, it fit in there, that's fine, but really wasn't necessary. Even had screw holes, one's going to screw it all in, but I ended up gluing it. So let's get back over here. We can go ahead and delete that. Now you'll notice I have this gray and goldish looking parts as well, because I didn't want to just do a black acrylic with LED lights. So that's why I got the recycled cast acrylic in the silver and gold for these parts. And basically all I did was on here, I took that, I offset it in to create, we zoom in, you can see here, there is this, let's change here, we're going to, there you go, this blue part here. So this right here, this blue line is going to be our inner pocket cut, because I want to be able to recess the silver part and the gold parts of the comm badge into the black and then glue it in. And then this is our cut piece. And you see, I gave myself a little bit of room there. I mean, we're talking 0.25 millimeters spacing. And it fit really well. And you can't even notice there's a gap on the actual piece. And I did that for both this center part and the side parts. You can see there's just that little gap there. Now, one of the other things you can even tell here, and this LED light is running a little bit closer to this one than we have a gap here. And in all actuality, I would actually move both of these a little further out. Not a whole bunch, but I probably give myself another 2, 3, maybe 4 or 5 millimeters. I don't know. Have to play around with it a little bit. But I would give myself a little bit more space right here. And then, just like we have this blue line as our outside cut, these blue lines are our inside cuts here. To cut this out and have taken out so we can see through there. So while we're talking about design, they're not just, the spacing between here. I also want to talk about this. I was saying, hey, we're just going to use the bit. And I was thinking, hey, I'm going to get a nice rounded corner. Everything's going to be nice and, tight right here. Actually, I got a little bit of gap. And that's because when you bend this, it goes in on itself. It's no longer that solid 6 point whatever millimeters thick. And so I do have some gaps right here and right here. Now, did it take that turn? Yes. But these right here, these corners right here, these sharp turns, I would round them out. That would be something else I do differently in the future. Not having those sharp turns, those areas did not turn out the best. This one was actually kind of fine. This is I would try to keep things probably around that kind of bend right there. This one was all right, but these tighter ones, these smaller ones and 90-degree ones, sharp turns, I would try to stay away from them. Can you do them? Yes, but you will get a little bit of gapping with the LEDs and the acrylic. All right, let's talk about the cam. Now, we touched on a few of the cutting paths while we were talking about the design, but let's take just a quick look in the cam software and just kind of look them over. And a couple of things I did experiment with in EtzelCam. I'm still playing around with it. Yes, I have been trying to use Pixel CNC as well. I am just not finding it as user-friendly as EtzelCam is. But as you can see here in this bottom part of the standoff for the wall, you can see there's these two little outcuts here. And that is the overcut function. So, when I was designing, I was keeping in mind, I was like, okay, I got this small bit. I need to make, undersize things so things fit in. And then I was like, oh, wait, it has overcut. So it's going to come in here and take my 2.15 bit and make these little cuts out. Let's see here. Because if I didn't, this corner would be rounded. But with that overcut, now my piece would fit in perfectly fine. If I hadn't made it shorter, that is a nice little feature in EtzelCam, and I'm sure there's other cam softwares out there that have that as well. And so let's come over here and look at our wiring. This is our all the way cut through part. So that's why it's going 5.82. And this right here, this is for the large part of that end cap to fit in. So our wire goes in here, cut all the way down through, and then this is just the place where our end cap can rest in. So we're only going down 4 millimeters. Now, I did go down 3 total millimeters, which is half of the depth of the acrylic. Nominal, let's just say that it would really be 2.8 something because it came out to 5 whatever it was. And I went 3 millimeters down. That way my side lighting would still show, but it was recessed in a little bit more, and my silver and gold would still pop out and give it some depth. Not really much special here. I did push up my 6.35 millimeter acrylic bit to 1,320 millimeters per minute, plunge of 450. And then one of the other things I was playing around was the plunge angle. So it came in at a 45-degree angle while it was cutting. So it wasn't just going straight down and across. It was giving itself time to get in there, start cutting, and instead of just down plunge and trying to take everything out in one fell swoop. So taking some of the stress off of the bit. All right, not much else in terms of, the CAD CAM part, the design part of it. So next step was to get this on the long mill, and that was fun. Let me tell you, That was the simplest part. Everything else took so much longer. This took me a total of, 30 minutes or less. That's what it felt like. It was probably 45 minutes, but setting up everything to record, getting all the lighting, getting everything ready, getting the material set down, switching it in and out, doing the bit changes, it did take a little bit longer than if I hadn't had to be recording all of it. However, while the black cut great, it really did. I did notice on the gold and the silver, there was a lot of static. I mean, a lot. Now, I'm used to acrylic having a little bit of a static charge and kind of feeling its presence, quote unquote. But this gold and silver, man, I could feel the hairs on my arm standing up as it was cutting, and I just sat there keeping my fingers crossed that everything kept cutting. There were no issues, and I didn't have, the long mill stop or anything on me. But just be wary if you're going to use that recycled cast acrylic, that it does have a static charge in it. It puts off a lot more static energy than some of the other acrylics you might be used to using. Well, that's going to wrap it up for part 1 of this video. In part 2, we're going to go over putting it all together, getting all this wired up, and yeah, this rat's nest, but don't worry, we'll get that cleaned up in the next video as well. We'll talk about coding and how you can get your button to change the different lighting effects and how you can switch them up and get them to work for your project. Let's give a big shout out to our sponsor, CNC Labs. A big shout out to all of you who watch these videos. And remember, until next time, keep making stuff.